Assalamualaikum and very good morning to Media Sakina. Today we are going to present about nanomaterial of kinetic. So my name is AMINUDDIN bin ZAINUDDIN. Today I would like to talk about the introduction, the definition and the example. So let me bring the introduction first. So nanomaterial is material science that always tag along with the achievement that improve our quality of life. It's not matter of natural selection, but during this continually involved process, only the best material survive. The first use of a lead that back to 4000 before century at Egypt and later had several applications like piping during the Roman Empire. There were enormous progress made in science which translated into evolution of the field of nanoscience and nanotechnology. We also push off study of nanomaterial. Nanotechnology caused a revolution in the material field because of handling of material internal structure had never been performed at such small scale, such as precision. So, what is definition of nanomaterial actually? According to the recommendation, a nanomaterial means a natural, essential, or manufactured material contain partial in an abound state, or as an cigarette, or as an logarithmic, where for 50% or more of the partial in the number size distribution, one or more external emission is in size range 1 nanometer to 100 nanometer. The demonstration will be used primarily to identify material for which special proportion might be applied, for example for reassessment and labeling ingredient. Those potential proportions are not part of the definition but specific negation which the definition will be used. Nanomaterial can occur naturally by create as byproduct of combustion reaction or byproduct purposely door engineering to perform special function. This material can have a different physical and chemical properties to their from counterpart. So there are many examples of nanomaterial, such as healthy care, which is nanoparticles are being developed to assist the transportation of chemotherapy drug to directly to cancerous growth. They are also used in aerospace, which nanotubes are used in composite for to bend in response to application of electric voltage. Aerometer also use nanomaterial, which is use nanowire zinc oxide, nanowire in flexible solar cell, as well as to play a role in the treatment of polluted water. Commercial industry also use nanomaterial, which is use mineral nanoparticles such as titanium oxide was used in sunscreen due to the poor stability that conventional chemical UV production they offer in long term. Sport industry also use nanomaterial, which is this sport industry has been producing baseball ball bat that have been made with the carbon nanotube. And not surprised also that military also use nanomaterial which use on mobile pigment nanoparticle to pursue better form or camouflage.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Zaiful Alif IZHAM bin ZAINURIN. Right now I will continue my friend's presentation. So I will start with fabrication. So in this report we are only going to focus about nanomaterial in water treatment only. So actually there is a lot of method that we can use. For example, we have chemical precipitations, ion exchange, adsorption, membrane filtrations, coagulation, flow coagulation, flotations, and electrochemical methods. So actually nano-absorbent are nanoscale particles that produced from organic or inorganic material. So the main thing that we use in this method, because of it have higher affinity, high porosity, small size, and active surface. This is the most important thing that we can use in water treatment. because in water treatment we're going to use this nanomaterial like a filter. So the smaller the porous, the better it will be effective. So there is a lot of method in produce this nanomaterial. Some of them use a lot of step and quite expensive, but some of them also just a simple one and cost effective. So we need to remember that in nanomaterial, the higher the surface area to volume ratio, the better it is. So this is because nanoparticle have a greater number of active site for interaction with different chemical species. To get better result for the removal of pollutant from wastewater, nanoparticle are becoming new alternative for the treatment of wastewater. So there are a few example of nanomaterial available. We have carbon-based material, metal oxide nanomaterial, and miscellaneous nanoabsorbents. So in this report, we only focus on one, which is the carbon-based material. Carbon-based material, for any absorption process, an absorbent having large surface area, poor volume, and proper functionalities is the key to the success. Currently, many different porous material have been developed, such as activated carbon, pellet clay, zeolite, mesophorous oxide, polymer, and metal organic framework. However, none of them are quite effective yet. So the most effective one that we get right now is carbon nanotubes and graphene based material. Carbon nanotubes are one of the allotropes of carbon, and this can be considered as various structural form of carbon element. We also call as CNT. CNT are composed of cylindrical shape rolled up in a tube-like a structure. There are two types of CNT, which is the single wall carbon nanotubes and multi-wall carbon nanotubes. You can see from the picture what make them difference. So for the single carbon wall nanotube, it actually composed of a single graphene sheet with a roll up. Meanwhile, for the multi-wall carbon nanotubes, multiply of graphene roll up sheets. So you can see from the picture the difference. So next, we move to the graphene based material. Okay, graphene is actually a substitute for the CNT and is an ideal material for water treatment. Compared to CNT, the utilization of graphene based material as absorbent actually may offer several advantages. First, single layer graphene material possess two basal plane, which is available for pollutant absorption. In contrast, the inner wall in CNT are not accessible by the absorbate. Second, graphene oxide and reduced graphene oxide can be easily synthesized through chemical exfoliation of graphite without using any apparatus or metallic catalyst. So actually, graphene based material serve as an efficient absorbent due to the large surface area and electron rich environment. So due to the strong functional group on graphene oxide surface, graphene oxide will be a potential absorbent for metal oxide compensation through both electrostatic and coordinate approach. So move to the application. There are several important applications for nanomaterial. As we know, we use it in the water treatment itself. Another example is aviation, chemical industry, optic, and many more. So as I mentioned earlier, nanomaterial is very useful because it has small size compared to others. So in water treatment, it's really important for that material to have a small porous because the better the smaller the porous, the better the filtration. So actually nanomaterial also have been incorporated in nanostructure catalytic membrane that can in turn help enhance water treatment. So in this report, we provided a review of the most common and popular nanomaterial, like I mentioned earlier, which is the CNT, carbon nanotubes, and the graphene. So these two material is really important in water treatment as we use it commonly. So now let's move on to the conclusions. For the conclusion, nanomaterial is a great water treatment, has its absorption ability. Everything nowadays is related to nanotechnology, as our study and research getting better by every day. So we can make nano study even further. So nanomaterial have a major contribution to modern water treatment in various areas. The wide application of this nanomaterial have created more exposure opportunity to a much better water quality. In the future, more potential application of water treatment nanomaterial are supposed to be developed. In conclusion, more efforts are required to ensure the wide use of nanomaterial in the field of water treatment. Thank you.